Roblox is a massive gaming platform where all the games are created by users and players. Close to 95 million people use Roblox every day, and it recently released an AI-powered image generator that allows creators to make 3D objects in the game by using generative AI. I'm Jennifer Strong, and this is Shift.
Now here on the steering column is a device called Auto Cruise. You simply set the speed you want.
Self-driving robo-taxis are already on the road in 2 U.S. cities.
As the disk rotates, a mirror reflects the light in the way that depends on how the signal was recorded.
This is the 100 terabyte I present to you Electro, the Mono Man.
Ladies and gentlemen,
I would say that one of my greatest skills is my ability to interact with humans.
This episode, it's the latest installment of our oral history project. Harness the power of AI agents at scale, without vendor limitations. The agency, spelled AGNTCY, is the open-source collective building the Internet of Agents to enable seamless agent-to-agent collaboration. Explore use cases on agency.org now. That's agntcy.org.
From Zuckerman Spader. For 5 decades, Zuckerman Spader has been a leading litigation firm trusted by in-house and outside counsel, businesses, and individuals. With offices in Washington, Baltimore, New York, and Tampa, Zuckerman Spader serves clients throughout the country and around the world in high-stakes disputes, enforcement matters, investigations, and at trial. When the lawyer you choose matters most. Online at Zuckerman.com.
We are entering a phase in AI where you are able to create not just storylines and visuals, but you're actually able to create 3D content. So this is a remarkable stage for game development because gaming is inherently 3D and building 3D is really hard. So using AI to help us with that creative process is just a special moment. I'm Kiran Bhat. I'm a senior technical director at Roblox. I work in generative AI for gaming. So Roblox is a huge gaming platform. All the games on the platform are created by users and creators. So it's a UGC gaming platform. And behind the scenes, it's an API that exposes a game engine and all the capabilities that you need to build a game and also consume gaming independent of the hardware you are on. Traditionally, with AI and gaming, AI used gaming as a platform for AI algorithm development, right? So you would have simulations where there's a predictable outcome, and like you can think of the AlphaGo or chess games that were really fundamental in the development of AI. Even though the search space is large, you had a way to win. And so that informed the development of a lot of AI techniques, especially reinforcement learning. But over time, the modern AI techniques involving generative AI has made its place into gaming as well. And some of those involve creating new levels, creating characters and NPCs, creating sound effects, creating textures and materials, and character animation. So those are some of the areas where AI has been making inroads, but primarily as a tool for developers to create richer content. Now, we are entering a phase where AI is going to create content on the fly, which is what we used to do, use procedural techniques in the past. Now AI is kind of helping you generate content on the fly. And that's like the new frontier in AI. Let me give a quick demo of this 3D scene generation with large language models. So what I have in front of me is a 3D scene in Roblox, and I have an avatar of myself and my friend Morris, who's also joining me virtually in Roblox with his avatars. He's waving at me right now. And in front of me, I have a box, a text box, where I can type literally anything into it. I want to type a scene of a village set in Asia in winter. So that's a prompt that I want to type in. And let me just go ahead and type that in. And the idea is that once I type this in, you'll see a 3D world that is generated based on the prompts that I've typed in. So let's try a Japanese, I'm typing now, Japanese village in winter. I'm saying there's a central pagoda and a few huts with pine trees around it. And I'm going to say there is a traditional gate with lanterns. Okay, so this is the prompt that I am typing in. And there's a generate button right next to the prompt. When you press generate, what happens is the text is processed by the large language model, the 3D LLM, as we call it, and it constructs a programmatic representation of what we typed in natural language. And what I'm seeing in the screen in front of me is the code that is a representation of my prompt. And then soon the code gets transformed into boxes where these objects would land. And the boxes become 3D geometry, which represents the pagoda, the huts, the trees. And right now I'm seeing the geometry show up. And after the geometry shows up, you also see the textures or the colors appearing on each of these meshes. So right now I have the gate showed up. My friend Morris is running around. The trees are here and he's anxious to generate something, I think. And I see him typing something. Go ahead, Morris. Oh, and he typed add a cart, a snowmobile, and a giant cat statue near the gate. Okay, so those are the things that Morris wants to create. But you can see how, this is a very collaborative process where we as humans are interested in a concept. We type what we want as prompts, and the language model generates the content in 3D and lays it out in 3D in the scene. And we take turns in producing the world that we are imagining together. And so what I'm seeing now are these boxes where the objects are going to show up. So I see a cart, a giant, cute cat statue appeared. And then I see a snowmobile. So I am going to go next to the snowmobile. And one really cool thing is the language model can add code to the objects and make them functional. So what I'm doing right now is I'm sitting on the snowmobile, and the snowmobile is actually, you can drive it around. So I'm actually driving around the scene. Oh, Morris is actually driving on the cart. Maybe we can have a cute race that's going on. Actually, we're racing right now, bumping into each other in 3D. But you can see how this can be really fun, right? You build objects that you think should be part of the scene. And some of these objects have functionality, which we call 4D. 3D plus functionality is 4D. And the AI can build all that code for you so that you are focusing on the gameplay and you're arranging things if the original layout is not as you expect. Now, one other thing that happens is because we have connected a language model into a game engine, Roblox is a 3D game engine, we can actually do other effects. So, we started out with a Japanese village set in winter. I added a small prompt that makes it snow. So now what's happening in my screen is when I type make it snow, you can actually see snow falling in the scene. And again, this is the kind of experience that a combination of a language model embedded in a game engine allows you to do very easily, just like how you're able to drive these objects because the driving capability is already, and physics capability is already in the engine. And one last thing I do typically when I design these scenes is I want to see how these scenes feel at different times of the day. So, right now the scene was set up where there was actually a nice background of mountains, which the AI selected. But now I want to see the scene in evening time or at night time. So I'm actually switching the time of the day to night. And when you do that, something really cool happens. So what you see is, you see the stars and the moon, the lighting becomes dark, but you also start seeing the lanterns that we had created in the original prompt start to glow up. And this is really beautiful because I think the AI model understood that the lanterns need to emit light and added code to emit light in the scene. So, these are the kinds of functionality where you're producing a fully functional interactive 3D world, and it's a human and an AI working together, or here multiple humans and AI working together to produce the full experience. The big breakthrough is in being able to encode geometry, which is 3D, with the same language that text uses for encoding its weights in a neural network. So, and by that, what I mean is, if you look at the text language models, they encode text with what's called tokens. We figured out a way to tokenize geometry, which can be trained in the same method as how you train text tokens. So by combining geometry and text tokens into the same architecture, we are able to now allow language models to express concepts in 3D. That's one of the big insights that allows us to get here.
AI agent collaboration isn't all that easy for enterprises. As an open source collective, the agency, spelled AGNTCY, is building the Internet of Agents, a shared collaboration layer where AI agents can discover, communicate, and collaborate. To learn from AI innovators such as Cisco, Crew AI, LangChain, and MongoDB, visit agency.org and explore use cases now. That's agntcy.org.
We're seeing a lot of convergence in the major classes of generative models. The community pursued transformer-based models for language modeling and diffusion-based methods for image generation and 3D in the past. And what we are seeing is a good convergence of these two models. And that's really exciting because language models are very good at next token prediction. So it's like, you can imagine you're writing a line and you can say tab and says the next word. You can keep pressing tab and you can complete a sentence. So you can think of the world being filled in with a next token type architecture. But the details of these objects are really rich when you model it as diffusion models. So what I'm really excited about is to see these two worlds come together, and where you can get the power of autoregressive models for reasoning and next object generation while getting the richness of diffusion model for detail. So I can't wait to see that happen quickly. From a technical perspective, building 3D models is just insanely hard because the amount of data that you have in 3D is substantially lower than what the amount of text and image data that's out there online. So what we found is that cracking this puzzle of tokenizing geometry and producing a sort of a general purpose 3D model turned out to be much harder than we originally anticipated. And I think this is true for the community as well. They are finding that 3D is just so hard to do. And so we are making really good early progress in 3D. But for us, for Roblox, the most interesting thing is functional 3D objects, which is, if you have a door and a building with a door, you want the ability to open the door, right? So it's not just about producing 3D, but it's actually about producing 3D that is functional in a gameplay setting that makes it really interesting, right? So if you create an avatar, you want the avatar to be animatable, right? So those are the aspects of 3D that that makes it surprisingly challenging. So people who are not thinking about 3D, when they think about 3D generation, they don't think about these aspects of how 3D gets used in a downstream application. And so sometimes those two challenges combined with the fact that there isn't enough data makes this a very hard but a very exciting problem to work on. So at Roblox, one of the big use cases for AI is to keep the community safe. And by that, we mean there are different types of communications that happen on the platform. So people communicate with each other once they are in the platform with their 3D avatars. That's how you come into the experience in Roblox. Once you're in the platform, you can communicate with each other via text, and some applications allow you to communicate with voice as well. So those are the two primary mechanisms of communicating within the platform. We can think of three axes of safety here. So the first is that the content itself, the 3D content, has to be safe. There's a clear list of requirements that are considered safe for different age groups, or acceptable for different age groups. And I think one of the things that where we use AI is to automatically moderate if the content you are trying to upload to the platform is safe or not. So that's 3D safety, where we can analyze the 3D content as a developer that you're trying to bring into the platform to see if it actually matches the terms of service. And if it does, then your content gets accepted and others can see it. Now, there are two other aspects of safety when players are playing and communicating with each other on the platform. And as I said, there's text and there's voice. With text, what we do is we filter the text in real time and assess whether the content is safe. And because of the nature of the medium, we have to analyze your conversations for through a large period of time to actually detect different kinds of safety vectors. And this is even harder with voice, because with voice, people are communicating with each other and it is happening in real time. And we've developed over the course of the last few years a voice toxicity detection system, which can analyze communication in real time and detect if you are violating the safety terms on the platform. And this is again a generative, an AI model, a transformer-based AI model that can detect if you're violating the terms by detecting certain types of toxicity. And this has been surprisingly effective, because what we do is if the AI detects that something is not safe, we initially nudge you. We send you a nudge on the platform saying that, hey, look, please don't behave this way. And if you continue, behaving the same way, and if you continue violating our safety standards, then there is a policy violation and you may get thrown out of the platform. So this is the kind of situation where at scale, AI is super helpful in making sure that the community is safe. And the toxicity detection it does a number of different things. It analyzes the voice for its tone and content. And that's one difference between text and audio, is that you don't get that tone in text, but in the audio, you can detect some of these cues. But the majority of the toxicity is in what you say. Of course, it's also how you say it. But in what you say, it can be not just a word or two words. It could be things that you say across a long period of time. So we have to continually analyze the voice chunks to determine whether something is toxic or not, right? And even when we detect that something is toxic, we do analyze it over long periods of time to really understand how toxic it is. So it's some of the things like, if you are using some keywords that are considered toxic, that those are easier to detect. But some categories like, bullying are much, much harder to detect. So you need a much longer context to understand if you're violating, if what you're saying is toxic. So that's why it's a much harder problem, but that's also where transformer-based AI models are very good at handling these problems. But the challenge is, at our scale, deploying techniques like this in a scalable, cost-effective way is really, really challenging. And I think that's where, a lot of the innovation is in building models and distilling it to smaller models, which can very effectively be deployed and scaled on our platform. So it's a combination of figuring out the science correctly, but also figuring out how to engineer it and distill these models to be small enough that it's really good at doing one task, which is toxicity detection, as opposed to these other models that we talked about for 3D, which are really good at doing lots of things.
This episode was produced by me and Emma Cillekens and mixed by Garret Lang, with original music from him and Jacob Gorski. Thanks for listening. I'm Jennifer Strong. Harness the power of AI agents at scale without vendor limitations. As an open-source collective, the agency, spelled AGNTCY, is building the Internet of Agents to enable seamless agent-to-agent collaboration. For business leaders, this means faster innovation and scalable solutions tailored to the multi-agent software your enterprise is creating. Visit agency.org to explore use cases now. That's agntcy.org.